Suppose we have a set of data, x1, y1 through xn, yn. This is called the training data. Okay, now each xi here, each xi is a vector, xi1 through xip, of measurements where xi1 is an instance of the first input variable, x1, xi2 is an instance of the second input variable, x2, etc. Now, x1 through xp, those are called features. Or predictors. Okay, now y1 through yn. Okay, so these are little y's. y1 through yn are instances of the output variable y, which is called the response. In linear regression, we assume that the response depends on the input variables in a linear fashion. So y equals f of x plus epsilon, where f of x is equal to beta 0 plus beta 1 x1 plus dot 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 beta p xp. Okay, now here epsilon is called the error term. And beta 0 through beta p, those are called parameters. Okay, now we don't know the values of beta 0 through beta p. However, we can use the training data to approximate the values of beta 0 through beta p. Okay, so what we'll do is look at the amount by which the predictive value f of xi differs from the actual value y sub I. Okay, so we look at the amount by which f of xi differs from the actual y sub I for each of the pairs x1, y1 through xn, yn. Okay, so this is the training data. Okay, so we have y sub I minus f of xi. as the difference. We then square this and take the sum for I equals 1 through n. Okay, so we get the sum y equals 1 to n yi minus f of xi squared. Okay, so we have a sum of squares. This is called the residual sum of squares. Okay, and it's denoted RSS of beta. Like this, where beta is the column vector of beta 0, beta 1 to beta p. Okay, we want the residual sum of squares to be as small as possible. Essentially, this means that we want our predicted values, f of xi, to be as close to the actual value y sub I as possible for each of the pairs xi, yi. Now, doing this will give us a linear function of the input variables that best fits the given training data. In the case of only one input variable, we just get the best fit line. In the case of two input variables, we get the best fit plane, and so on for higher dimensions.